Assalamualaikum and hi everyone. My name is Muhammad Ikmal bin Harun. Matrix number 01DDT23F1051, and I will continue with the data structure mini project presentation. I will start with question 1. It says that Ayman joined a programming competition in his faculty. He was given 1 week to solve a problem. Ayman asked for your help to construct a program to reverse the word that entered the program. For example, if users enter ALI, the output will display ILA to the screen. Ayman wants you to use a stack to store the input. Let's move on with the coding. Okay, firstly at the top here, extract include iStream. This allows us to use input and output functions. And then over here, max 100 sets a constant maximum to 100, which will represent the maximum size of our stack. Okay, over here, the stack class is created to hold the stack operations. Inside it, this char here, an array of char type with a maximum size of maximum, which is 100, to store the characters of the word. And over here, a variable top initialized to -1, which keeps track of the current top of the stack. -1 will indicate that the stack is initially empty. Move on with public here. Void char push. Void push char C is a method that adds a character to the stack. It will first check if the top is less than maximum -1 to make sure that the stack is not full. Over here is increments by 1 and places the character C at this new top position in the stack in the array. Char pop here is a method that removes and returns the top characters from the stack. It will first check here if the top is greater or equal to 0, which means the stack has element. If so, it will return the current top element, then decrement stop to move down the stack. If the stack is empty, here it will return /0, a null character, as an indicator that it's a empty stack. Okay, boolean here is empty is a method that check if the stack is empty by seeing if the top is -1 or not. If so, it returns true, otherwise it will return false. Continue. Main function is the starting point of the program. It will create an instant stack, allowing us to use the stack operation. String declares a string variable to input to store the user's word. Okay, enter word here so that the user will know to enter the word. Over here, reads the entire line of input from the user and store it in the input variable. Over here, for loop goes through each character C in the input word. Stack push will pushes the character onto the stack, so they are stored in reverse order when we later pop them up. This is reverse word to display to indicate the output. The while here loop runs as long as the stack is not empty. Over here, remove pops the character from the stack and print it, effectively printing the word in reverse order. Over here, move the cursor to a new line after the reverse word is printed. Return 0 indicates that the program finished successfully. And that's all for question 1. Thank you. And I will pass the presentation to Tiun.
Hi everyone, I'm Tiun. Today I'm going to discuss about data structure mini project. Now I'm going to explain about question 2. The question 2, you are hired to develop a food ordering system for XYZ restaurant. The system should use first in, first out, FIFO% to manage food orders. When a customer places an order, it gets added to a stack of orders in the kitchen. To handle the orders, you decided to use a queue linked list data structure where each node in the linked list contains a stack of order for one customer. As cooks complete each order, they pop it off the stack, display it on the screen, and prepare it for delivery to the customer. Write a C++ program to stimulate that process. So for the coding is like this. So this basic, and here we create a structure to represent a stack node for orders. And here we need to create a class to represent a stack for orders. And for here, we push an order onto the stack. And here we need to create a pop function, and this is used to pop an order from the stack. For here, we will create a structure to represent a customer in the queue. And order stack orders, this is a stack to hold the customer orders, and this is the pointer to the next customer in the queue. And here we create a class to represent a queue of customer, and this is the customer address. One is pointer to the front of the queue, and this is pointer to the rear of the queue. And here we will add a new customer to the queue. For this one, we will add an order for a specific customer. And for this one, we will process order, and we will pop from the stack for the front customer. For this one, for this block of code, we will check if there are orders to process. If there is no order, it's empty and no order for. And this one, this block of code, it will process orders, and this one, it will remove the customer from the queue after processing. And queue for here, queue is now empty. Delete current is for free memory. And for this block of code, we will display the queue. We will use to display the queue. And inside the main function, we will enqueue 3 customer, Alice, Bob, and Charlie. And for Alice, it will order burger, fries, and for Bob, he ordered pizza, and Charlie ordered pasta and salad. And here we will process order for each of the customer. And the first line of code is used to process order for Alice. Second line of code is process order for Bob, and the third one is for Charlie. And here is all about my code, and you'll see the output. customer in queue. Just now we enqueue Alice, Bob, and Charlie. And for Alice, it will order fries and burger, and Bob order pizza, and Charlie order salad pasta. So we use the FIFO concept, first in, first out. So the cook is gonna make the fries first and burger. So that's why fries and burger will be pop out first. That's all from me, and I will pass to the next member.
Hello, my name is Firdaus, and this is question 3. First, write a C++ program to show the implementation of binary search tree using linked list. Your program must include basic operation in binary search tree, including creating the binary search tree, inserting item into binary search tree, deleting item from binary search tree, and displaying data in binary search tree. Now let's move on to the code, which we will have. This is the code, and all of this is code, and this is the last code. So to take a closer look, let's open VS Code. Now let's see the VS Code. This is the file that the code is in. So first we have include IO stream. This is the basic stuff of C++ to use input and IO, input and output. Then we have using namespace standard. So we don't have to write std on in all the code. Here we will declare a structure. The structure name is node. So in node we have data. Then we have pointer left and pointer right. And we have a function right here, which is node pointer find min that will accept node pointer root as a parameter. So in this function, we will do while, which is a loop. Root pointer that is pointing to the left is not equal to null. Then root is root pointing to the left. So here basically, if the pointer that is currently pointing to the left does not equal to null, then we will point the pointer to left and we will return root. So here we have the delete function of the binary search tree. This function will set parameter root, pointer root, and data as a parameter. So let's get to the first line, which is if root is equal to null, then we will return root. So basically in root there is nothing, so we will return nothing in root. This f data is less than this data, the data we insert as parameter is data is lesser than the data that is currently pointed by root, then we will delete the data that is pointing to the left. Here, this is a recursion function, so we will recall back the function to recall this function to run all of this again. If data is lesser than root that is pointing to data. So else if again, another statement, if a statement, data is bigger than the data that is in the root, then root pointing to the right will equal to this function. We recall back this function. Else, in else we also have another if else statement. If root is bigger than if root is pointing to the left, basically I will call this pointer that is pointing to the left is equal to null, and pointer that is pointing to the right is equal to null. It will delete root, so basically the entire tree will be gone. But as if root that is pointing to the left is equal to null, then we will declare a temporary pointer that will copy the entirety of root. Then root will equal to root pointing to the right, and then we will delete temporary. What this does is we will move the root to the right, and then this all root that we have deleted will be deleted in the tree, because the tree right now we are using a linked list. To delete a linked list, you have to do a function like this, or the BST tree that we want to delete won't be deleted. And then we have as if root pointing to the right is equal to null, then we create a temporary pointer that is equal to root, then root is equal then root is equal to root pointing to the left, then we will delete temporary. Else, this is the last one, temporary is equal to find min, so we will call the function that we have created here. A pointer that is pointing to data, root pointer, will equal to temporary pointing to data. Then root pointing to the right is equal to left is equal to delete. Then we pass this parameter. So basically we'll call this function yet again because it is a recursive function. Now let's move on to insert function. Here we have insert. This is node pointer is our data type, and here it will receive root pointer and data. So if root is equal to null, then root is equal to new node. This is basically a way to create a new node so we can put item into it. So here we have new node, then root pointing to data we equal to data, and root pointing to the left and root pointing to the right will equal to null, because this is the first pointer that we have created. Then we only have the data in it. The right and the left pointer will become to null or 0. Else if data is lesser or equal to root that is pointing to the data, then root pointing to the left will run this recursive function yet again to insert the number. Else root that is pointing to the right, we will recall back this function to create a new node. So basically, if root that is pointing to the right, this is the last. If this two is false, then it will go to this. So right pointing to the right, we will call this function and do the entire code once again. Then we will return root. Now this is for the search. We want to search the binary search tree. So we have the parameter which is root and data. If root is equal to null, then we will return false. As if root is bigger, root that is pointing to data is equal to data, then we will return true. As if data is lesser or equal to root pointing to data, then return search root pointing to right data. So basically, we'll repeat back this function. It's a recursive function again to get this one, to get this code going to be true. Alright, now let's see the function display data root. So in this function we have root pointer, and we also declare integer number. This function will basically ask the user to enter a number they want to search. And here we have the main function, node pointer root is equal to null. Then we will insert all of this number, 5, 10, 3, 4, 1 and 11. Then we will call this function to get the user to enter a number they want to search. Then we want to delete 5 because 5 is our root. We want to delete 5, and then we will display data root. Then we will add the user to again search a number. Alright, now let's take a look at the terminal. Here we want to search the number 5. Yeah, number 5 is fun because number 5 is in the binary search tree. But now we have deleted the 5. If we want to search for 5 again, now it will not be found because we have deleted it in the binary search tree. That is all for me. Thank you.
Everyone, my name is Aqmar Fahim Hakimi bin Hanzi. My matrix number is 01DDT23F1078, and now I will show you how to solve the question number 4. The question asks to illustrate the step to find the target key of 52 by using A. Linear search method and B. Binary search method by using the table given. So we need to answer the question A first, which is the linear search method, and the question asks to find the 52, which is in the index number C, but it's not the simple because in linear search method we need to go one by one index until we go found the 52 item which is in the index C at index 6. So first of all, we will move to the index 0 first, and the index 0 contain the item 8 which is not equal than 50. So we will move to the next step, which is in index 1 with the item contained in here which is the 11, but 11 is not equal to 52 also. So we will move to the next step, which is in index 2 contain the item number 19, but 19 also is not equal to 52. Then we will move to the next step. In index 3, the item contained in the box index C, which is the 25, also is not equal to number 52. After that, in index 4, item in index 4, which is the 34, is not equal to 52. We will move on. In index 5, the item contained in the box, which is the 47, is not equal to 52 also. And last but not least, in index 6, which is contained the item is 52. So the 52 is equal to 52. After we found the 52, the linear search method will stop here and not to continue to the index 7, 8 and 9. Now we will move to next question, which is the binary search method. In the binary search method, first of all, you need to remember to always put mark in front and first and last on the first and the last item. So how to find the middle, which is we need to add up the first and the last index, which is the 0 and 9, and we will divide with this, and we will get the middle in the index number 4 that contains item 34. After that, you need to compare the item that need to find, which is the 52 here, with the 34, and we will get here the 52 is bigger than 34. So we need to find the item next to the 34 item, which is after the index 4, which is the 5, 6, 7, 8 and 9. We will move to the next step. We need to mark the first in the index 5 and last in the index 9. So the way to get the middle, which is 5 plus 9, you will get the 14, and divide by 2, we will get the 7 in the index 7 that contains item 55. After that, we also need to compare the items with the 52, the question up, which is 52 is less than 55. So we need to find the item behind the 55, which is the item. We need to move the next step, which is we mark the 47 and 52 with first and last mark, and then we also need to find the middle, which is 5 plus 6 will equal to 11, and divide by 2, you will get the middle, which is the 47. After that, 52 is bigger than 47. So we will see here that the 50 beside the index 5, which is the index 6, contain the 52, which is the answer for this question. So that's all for me. Thank you.